Hey guys, I'll be off this week, unfortunately, because my wife has COVID. How dare she? So I'll be just uploading little videos at the start of each lesson to explain what I would like you to do for that day. So the lesson for today is on improving titration accuracy. So I've uploaded this lesson on Google Classroom, and once you've finished watching this, I'd like you to go on there and have a read through it. But just to talk you through it quickly, there's a crossword for you to start off with a bit of a warm up. So good luck to you. Once you've done that, what I wanted to talk to you about was how do I improve my titration accuracy? So we know that titration is finding the concentration of an unknown solution using a known solution. Uh, and the way you do that is you have to find the volumes of both as well, and you plug them into your calculations. Now, the volumes are very sensitive, so even a small change, a small drop here and there can alter your concentration. And remember, this is all about being as accurate as possible. So, how can we be as accurate as possible with titration? Well, here are some good practice techniques. Firstly, rinse the conical flask with deionized water prior to starting to ensure there's no other chemicals that will react. Now, you don't have to dry the conical flask because the water is not going to change the number of moles of the dissolved solute. So it doesn't actually alter the balance of the reaction. So just rinse it and kind of shake it off, and that's all you need to do. When you're calculating your concentrations and volumes, the uh, final readings are always calculated to two decimal places, please. So, for example, concentration of 1.13 moles per liter. When you add your indicator, just 2 to 3 drops to make sure that it doesn't react with anything in the conical flask. When you start your titration, you're going to do a number of trials to get an average. The first trial you always do is called a rough titration. And what you do there is you do it quite quickly, which will be inaccurate, but at least you have a ballpark figure of where the neutralization point is going to be, the equivalence point. So then you can start your accurate titrations and really slow down and hone in on that kind of ballpark range that you sussed out in the first rough titration. So you don't include your rough titration when you're calculating out your averages, just to let you know. You need 3 titrations with concordant titers. Concordant means they are similar to each other, and the range that I would accept from you would be within 0.3 mils of each other. So once you have 3 readings that are within 0.3 mils of each other, then you can add them up and average them and use that in your calculations. When you're titrating, swirl around the conical flask so that you can mix the solutions. Don't introduce any other apparatus in there. And I would definitely swirl after each drop and just wait a few seconds, because sometimes the indicator color change will occur a little bit delayed. If there's any drops that from the burette that enter on the side of the flask, or even from the pipette as well, wash them down with some deionized water so that every single drop is counted for. That's how pedantic we have to be. Now, in addition to these good practice techniques, you have to also remember your good practice techniques for pipette accuracy, which I've listed here from the previous slide, and hopefully you've all drawn pictures of this. And also your burette accuracy needs to be on point as well. So these are from the previous slides. So there's a lot of different ways that you can be accurate, which means there's a lot of different ways you can be inaccurate. And the assessment will be marked on how accurate you are. So the closer your reading is to my reading, the higher your mark will be. So for the rest of the period, can you please go to page 51, activity 4A, which is what we started the other day. This is involving calculations of titrations. Tomorrow I'll talk you through a titration simulator. While we can't do titrations in the lab while I'm away practically, the simulator is really good and it kind of replicates the real thing. So good luck, and don't give your reliever any trouble, please.